Hi, Rhonda. If you have any questions, you can just type them into the chat bar. And if you don't, you can always email me later if you have one. The equation of 3 lines. I'm trying to think what that would be. Let's see. Was it the one where you had to, you were given 3 lines and you had to find their slopes and see if they were parallel or perpendicular, maybe? Hi, Danielle. Thank you for attending, and you got your bonus points. And if you have any questions, you can stick around and ask them. Okay. So I'm going to work an example where we're given the equations of lines and we have to determine if they're parallel, perpendicular, or neither. Hi, Dana. So we are going to say that we have the equation 3x plus 4y equals 12. We have the equation 4x minus 3y equals 24. And we have the equation 4x plus 3y equals 6. And let's determine if these are parallel, perpendicular, or neither. Hopefully you can hear me. Let me know if there are any technical issues, like an echo or you can't hear my voice. Okay. So, looks like Emily's here. Okay. So I'm going to, let's see. This is called standard form, when you have a term with an x, a term with a y on one side, and then a constant term on the other. This is not a very helpful form for finding the slope of the line. We would rather get it in slope-intercept form, y equals mx plus b. So that means solving for y in each equation, and oftentimes students try to do this in their head, you know, especially since we're working in ALEX and have online homework. So we want to write out the steps. That's probably my best tip for not making an error on these. So the first thing we're going to do is always to move the x term over. So for example, in this first equation, we have to subtract 3x, so we have to subtract it on both sides. So what that means is that our equation is going to turn into, let me get a different ink color here. Our equation is going to turn into 4y equals negative 3x plus 12. Now we could put 12 minus 3x, but we prefer, again, that it matches this y equals mx plus b. So we want the first term to be the x term on the right. Now y is not completely by itself, so we need to fix that. Y is being multiplied by 3. So we're going to reverse that operation and divide both sides by 3. This is also a place, oh, excuse me, y is being multiplied by 4. Let me fix that. This is also a point in the process where students make some common errors, specifically when they're dividing, they divide just one of the terms by the 4, but in fact both terms need to be divided on the right by the 4. So let me make this a little thicker here. So we're going to then cancel these. 4 divided by 4 is 1y, or just y. And we're going to divide these. Negative 3/4 x. 12 divided by 4 is just 3, so we have negative 3/4 x plus 3. Okay, now remember the reason why we're doing this is because we want to find the slope. So you can see here that the slope of this particular line is negative 3/4, but we have to compare it to these other two lines. So let's keep going. If you have a question at any point during this explanation, you can type that in as well. All right, so in the next problem, we have to do the same steps. You see how in the first equation we first moved the x term over? We're going to first move the x term over. So that means we're going to subtract 4x from both sides. Okay. So what we're going to have then is negative 3y equals negative 4x plus 24. I'm going to check my screen here, make sure you can see that. Yeah, okay. All right, so what was the next step? Dividing by the coefficient of the y that's still there. So I'm going to divide, in this case, by negative 3. Divide everything by negative 3. So we're going to say y equals negative 4 divided by negative 3. We're just going to write that as a positive 4/3. Negative divided by negative is positive. And then positive 24 divided by negative 3 is negative 8. So that's our second equation, and remember, we're looking for the slope. So in the second equation, our slope is 4/3. Okay, let's look at the third equation. In the third equation, the steps are still the same. We always move the x term first, so I'm going to subtract 4x from both sides. I'm going to have 3y equals negative 4x plus 6. Okay, and then the next step is the same. We are going to divide by the coefficient of the y next, always. So dividing by 3 on both sides, we're going to have y equals, now negative 4 divided by positive 3 is negative 4/3 x plus 6 divided by 3 is 2. All right, finally we have our third slope. So let me highlight that. It's negative 4/3. Okay, I'm gonna make a new slide. I'm gonna give you a second in case you're writing this down to finish copying that last one. But on the next slide, what we're going to discuss is the slopes. We have line 1 has a slope of negative 3/4. Line 2 has a slope of 4/3, and line 3 has a slope of negative 4/3. All right, so copy those down. So let's see, line 1 had a slope of negative 3/4. Line 2 had a slope of 4/3. And line 3 had a slope of negative 4/3. Okay. So we have to remember that in order to determine if it's parallel, we need to see if the slopes are the same. Right? Because if the slopes are the same, the lines are going to run right next to each other and never bump into each other. We call that parallel. So, are any of these values equal? No, I don't see any pairs that are. So we're not going to get anything that's parallel. How about perpendicular? Perpendicular is a little bit trickier. Perpendicular means they meet at a right angle, and when that happens is when the slopes are what I call opposite reciprocals. So opposite reciprocal slopes just to give you an example, if you had a slope of 1/5, its opposite reciprocal would be negative 5/1 or just negative 5, okay? A little trick that you can do if you want to determine if two slopes would be perpendicular to each other, you could multiply the two slopes together and you're going to get -1. Okay? All right, so do you see any slopes that are opposite reciprocals of each other? I think there may be. I think that I see certainly some that are reciprocals, and we have a couple of different signs. So let's organize this. In ALEX, when you do your homework, they organize it usually like this. They ask you about the pair of lines, line 1 and 2. So line 1 and 2, we already said none of them are parallel, so we know they're not parallel. But are lines 1 and 2 perpendicular? Well, it looks to me like they are, because the reciprocal of 3/4 is 4/3, and line 1 has a negative slope and line 2 has a positive. Or if you wanted to use the little multiplication idea, negative 3/4 times positive 4/3, get a thicker line here, is equal to -1, because 4 goes into 4 one time, 3 goes into 3 one time, so we get -1. All right, so the answer to this portion is that lines 1 and 2 are perpendicular. Okay, let's compare line 1 and 3 now. I don't know how to pronounce your name. Nehemi, welcome to the chat. Nehema. Okay, and so our lines 1 and 3, they have slopes -3/4 and -4/3. So we already said those are not equal, they're not parallel, but what about perpendicular? Well, although -3/4 and -4/3 are reciprocals of each other, they are not the opposite sign. So the answer to that is no, they're not. And you would see that also if you multiplied them together. Yes, these would all cancel, but you'd have a negative times a negative is a positive one. So these are not parallel and they're not perpendicular, so we would say they're neither parallel nor perpendicular. And if we compared line 2 and line 3, line 2 is a +4/3 slope, and line 3 is a -4/3 slope. Obviously, they're not equal. They are opposites of each other, but not reciprocals. And again, if you multiplied them, you would not get -1, you would get -16/9 multiplying straight across. So this is definitely neither as well. Okay, so that's how you determine in those problems in ALEX where they give you 3 equations of lines and you have to determine if they're parallel, perpendicular, or neither. That's the procedure. Let's see, there's a question. Can you explain how to tell when a line is horizontal or vertical when ending in X or Y, because I'm stumped? Okay, so for example, when ending in X or Y. So are you saying that you saw something like 5 = 4 + Y? Something like that? Hi Jasper, welcome to the chat. Since you logged in, you'll get your bonus points, and if you have any questions, you can type them into the chat. You're welcome, Rhonda. So Dana, well, if you could find an example of what you're talking about, that would be helpful, but I am just gonna kind of explain what vertical and horizontal lines look like real quick. So, oh, like Y = -5/3. Okay, let's do that then. Okay, so we're gonna talk about vertical and horizontal lines. Okay, so the key thing about vertical and horizontal lines is that every single point on either a vertical line or a horizontal line has something in common. For example, here's my XY coordinate system, and I'm going to draw in a horizontal line. This particular horizontal line goes through the point 0, 2 and the point 3, 2. It also goes through the point -1, 2. And since it's horizontal, every single y coordinate is going to be 2. Okay, so the way that we write the equation for that is simply by saying that y always has to be 2. X can be anything that we want. Okay. One way of understanding why the equation turns out to be just y equals 2 would be to think about the slope. So we know that lines can be written in the form y equals mx plus b, where m is the slope and b is the y-intercept. Okay, and we also know that we can find the slope between any 2 points, and therefore the slope of this line, by plugging into the formula y2 minus y1 over x2 minus x1. So just as an example, let's say I found the slope between the point 0, 2 and the point 3, 2. So I'm gonna just randomly assign one pair to be x1, y1, and the other one to be x2, y2. In other words, I could have labeled them opposite. It wouldn't make a difference in the final answer. Okay, so using 0, 2 as my x1, y1, and 3, 2 as my x2, y2, I plug in. I'm going to have 2 minus 2 over 3 minus 0. Notice that in the numerator I get 0, and in the denominator I happen to get 3 in this case. But in every case, if I were to subtract the y coordinates, I'm going to always get 0, so I'm always going to have 0 in the numerator of my slope formula here. This would happen on any horizontal line because all the y values are equal. So your numerator always turns out to be 0. And if you recall, 0 divided by a number is 0. So we're looking at a line that has a y-intercept of 2 right here, and it has a slope of 0. So if we were to use the y equals mx plus b format, y equals 0x plus 2. But of course we don't write 0x because 0 times anything is 0, so it's just going to be y equals 2. Now similarly, if we have a vertical line, every point on the graph is going to have something in common. Let's see what it is. Jasper asked if we can go over graphing lines, and yes, we can do that. And Danielle asked if we can go over the vertical line test, and yes, we can do that too, no problem. Okay, so, but for now I'm going to keep talking about vertical and horizontal lines. So let's draw a vertical line now. All right, so here's a vertical line. And let's say it goes through the point 4, 0. Okay, well, that means if I know it's vertical and I go straight up to another point, I would have a point here at 4, 1 and a point at 4, 2, etc. So what we see in common with all of these pairs of coordinates is that the first coordinate, the x-coordinate, is always 4. So we can simply say that we're talking about the set of all points where x is equal to 4. Now, this case, vertical lines will always have the form x equals a number, just like horizontal lines always have the form y equals a number. And there's something interesting, though, about the vertical case because the slope turns out to be something strange. M equals y2 minus y1 over x2 minus x1. If I use any two of those pairs of coordinates, so maybe this is my x1, y1, and this is my x2, y2, then plugging in, we would have 0 minus 1 for my y2 minus y1 over, and then we're going to have 4 minus 4. Okay, so maybe you can see what the problem is here. I'm going to have negative 1 divided by 0. So remember, you can divide a number by 0. 0 divided by a number spells on for right on. You can do it. You get 0. But a number divided by 0 spells no. You can't do it. So what that means is that your result is undefined. Okay, the slope of this line is considered undefined. All right, so that's the basics of vertical and horizontal lines. So in the question that you asked me, like y equals negative 5/3, let's see how we would graph that one. So if you're asked to graph y equals negative 5/3, okay, what I recommend is not to try to memorize that when y equals a number it's horizontal, but try to just sketch it real quick. So even if I don't ask you to sketch it on the test, but I just ask you, is this a horizontal or a vertical line? What I would say is just make a little XY chart, and since it's saying y equals this number, just remember that means that no matter what the x coordinate is, the y coordinate is negative 5/3. So I'm going to just pick a few x coordinates and plot that, and that will remind me that it's horizontal, because when I go to graph it, I'm going to say, okay, I'm going to be 0, negative 5/3. By the way, negative 5/3, 3 goes into 5 one time with 2 left over. So it's like the negative version of 1 2/3. So it's lower than negative 1, but not quite negative 2. So it's down here somewhere, okay? So we're going to plot 0, negative 5/3. We're going to plot 1, negative 5/3. Really, that's enough to see that this is a horizontal line, okay? So whenever you see just no x in the equation, just a y, or vice versa, make a little chart. If I had asked you to graph x equals, let's do negative 7/3, okay? Again, make a little chart, but this time all the x values are negative 7/3. Pick a couple of y values and plot them. Now, negative 7/3, 3 goes into 7 twice with 1 left over, so that's like negative 2 1/3, a little bit past negative 2. So on the x-axis, I'm going to go a little bit past negative 2. So here we are at negative 2 1/3, negative 7/3. That would be, I didn't put it on here, but that would be negative 7/3, 0. Negative 7/3, 1 would be here. And negative 7/3, 2 would be up here. And we would see just by plotting those that we're getting a vertical line. Same thing with if you're asked the slopes of a horizontal and a vertical line, you can try to memorize it, but don't worry, if you forget which one's which, you can always figure it out. Graph yourself a little horizontal line, and you would see, if you try to find the slope of it, that when you subtract the two y values, you're going to get 0 in the numerator, and that means 0. So for example, here, negative 5/3 minus 5/3, and maybe 2 minus 1, you get, this changes to a positive, subtracting a negative is adding, so negative 5/3 plus 5/3 is 0, and then you'll get some number, it doesn't matter what, in the denominator, so you'll know that that is equal to a slope of 0. Repeat that procedure with the other graph, you would see that the slope is undefined. So that's pretty much everything you need to know about horizontal and vertical lines. So I don't know, did that answer your question, Dana? Okay, let me know if you have a follow-up question and I can come back to it. And in the meantime, I'm going to go to Danielle's question about the vertical line test. Okay. I'm glad you asked about that because we didn't have time to go over functions in class. So functions are going to be real important in college algebra. You're going to see these again if you take that class. In order to understand functions, you need to think about ordered pairs. A relation is something less specific than a function. A relation is just any set of ordered pairs. And the ordered pairs could be pairs of letters, like we could have the set AB and AD and CE. That would be a relation. It could be a set of numbers like 1, 2, 2, -3, -3, 1. It could be a set of names. I could say my first name is Quinn and match it up with my last name, Hearn, and Michael and Jackson. Okay, so it doesn't really matter what we're matching up. Only thing that matters is that they're in a particular order. So the first elements, the X elements, as we normally refer to them, the first part of the ordered pair, I guess I should say X coordinates, not X elements. The X coordinates are all the input. So the X is the input. This is the set of all X values for a particular relation is called the domain. The Y is always the output. The set of all the Y's is called the range. Okay, so that's a relation. Now the reason I'm telling you about a relation is because a function is a special kind of relation. So we're going to analyze these three sets and we're going to see if they are functions or not. Okay. The thing I like to say about functions is that they're good predictors, meaning that when you have a function, if I tell you the input, you don't have any doubt in your mind about the output. I don't even need to tell you that, okay? With a function, all I need to tell you is the input and you automatically know a single output that goes with that input. All right, so a function is a relation in which one input matches up with one output only, not two possible outputs. Okay, so let's look at the first relation that I gave you, which was AB, AD, CE, and we're going to see if it's a function. The way we're going to do that is we're going to list its domain and its range and draw arrows to what matches up. So here my domain is going to be the first coordinates. You don't have to list them twice if they appear twice. They're only once in the domain. So you're going to have A and you're going to have C. And then in the range we have B, D, and E. B, D, and E. And now when the input in the domain is A, what is the output? Well, I would have to specify in this case because the output could be B or it could be D. A matches up with both. C, there's no doubt about C. C matches up with E. But if I just were to tell you A, you wouldn't know which ordered pair I was talking about. So what that means is that this is not a function. Anytime the input points at more than one output, it's not a function. Anytime the X, in other words, matches up with more than one Y, it's not a function. Let's look at the next one. So we said that that one is not a function. Let me put up here, not a function. and it was because of the A. All right, let's look at the next one. 1, 2, 2, negative 3, negative 3, 1. All right, so we have a domain that includes 1, 2, and negative 3. And we have a range that includes 2, negative 3, and 1. All right, now for each input, do we know the output? Well, if I said the input was 1, the only ordered pair that has a 1 in the first coordinate is that one that points at the 2. And so that's clear. There's no doubt what 2 points at, that's negative 3. And there's no doubt what negative 3 points at, that's 1. Okay. So that one is a function. It does not violate that part of the rule that says that a function, for a function, you have the one input points at only one output. Okay. How are we doing so far? Let me know if you're having any trouble hearing me or seeing anything, okay? All right, so let's do the third set, but actually I'm going to add a person to the third set. I'm going to add my husband, Anthony Hearn. Okay, so for the third set, oops. Sorry about that. Okay, so for the third set, the inputs, the domain, are Quinn, Anthony, and Michael. Okay, and the range, the output would be Hearn and Jackson. All right, so if I said the input is Quinn, would you know the output? Yes, there's only one name that matches up with, which is Hearn. If I said the input is Anthony, would you know the output? Yes, it would be Hearn. No other options. And if I said the input is Michael, the output would have to be Jackson. Okay, this confuses people because they see the two different first names pointing at the last name and they think, oh, this can't be a function. But we did not say that you couldn't have two different inputs pointing at the same output. All we have to have is that we know with confidence when I tell you the input, you know the output without me having to tell you. And that's the case here. Okay, so I know that seems like a long introduction to get to the vertical line test. I know that was your question, but if you understand what a function is, the vertical line test becomes much easier. So let's take a look at, oh, by the way, let me write it down. This was a function. Okay, so we're just looking for a good predictor. And let me get my next slide ready for a moment. Hold on. Okay, so vertical line test. The vertical line test is a way of determining whether a graph is a function. See, The examples I just showed you, we had a list of ordered pairs. That's a different situation than when you have to look at a graph. Remember, a graph is just a plot of a bunch of ordered pairs. Hold on, I gotta go quiet my dog. Okay, sorry about that. All right, so let's look at a couple of graphs and determine if they're functions just by looking at the graphs. So, for example, I could have a graph that looks like just a straight line. Okay, so let's say my graph looks like this. All right, so notice that for any x values are our input, we only see one y value. So for example, maybe the line goes through the point -4, -2. There's not going to be another point on this line that has a y value of -2. And the reason why I know that is because I can look right here vertically. These are all going to be the points that have -2 y values, and this line is never going to hit that again. So remember, we're trying to figure out if for every input I can predict exactly one output, and the answer here is yes. And because no matter where I were to draw a vertical line, we would never hit two different points. So we would never have two different outputs, two different y values. So should emphasize x-axis, y-axis. We're never going to have more than one y value on any of these yellow lines. Okay, so let's look at a scenario where that doesn't work, where this one is a function. It passes the vertical line test, no double outputs. Okay, let's look at something where it fails the vertical line test. Sometimes you might have a circle. So here's the graph of a circle, and maybe this circle goes through the point 0, 2, and it goes through the point 0, -4. Okay, so right there you can see that we have one input, an x value in the domain, that matches up with two different outputs. So if I just told you the input 0, you wouldn't know which output I was referring to. So how does that relate to a vertical line? Well, notice that if I draw a vertical line through this circle, I hit more than one point. That means I have more than one y value for that individual x value. That actually happens in many places along this circle. Okay, so sometimes you will have graphs that are nice smooth curves like that. Sometimes you'll have graphs that look like maybe a bunch of dots. Okay, and so you'll have a graph that looks like this. Individual ordered pairs that have been plotted. Okay, and so here we can just identify whether it's a function or not by drawing vertical lines through every single dot, basically. And we're going to ask ourselves, in any case, did I hit more than one dot? And the answer is yes. And so what that means is that it failed the vertical line test, just like the circle did. So remember, this was not a function. And this is not a function. And you might not know the exact y values, but you can see that this 1x value has two different y values that match up with it. Okay, so when it turns out that the vertical line only hits the function in one place, no matter where you draw it, we say it passes the vertical line test. So this first graph, the line, passed the vertical line test, VLT. Okay, but when it hits it in more than one place in a single line, then a single vertical line, I should say, then that fails the vertical line test and it's not a function. So these two fail the vertical line test. Okay, so let's see. I think that was Danielle that asked about that. Did that answer your question, Danielle? And also, I just want to remind everyone, if you notice any sound or video issues, please tell me. Okay. All right, so Danielle, please feel free to interrupt me and tell me if you need more information about the vertical line test. But otherwise, I'm going to move on. And Jasper was asking about going over graphing in general. And he says, which direction to go with the slope? Okay, so that's a good question. So let's go ahead and talk about graphing lines and how to know where to go with your slope. Okay, so graphing lines using the slope and y-intercept is the topic. Okay, the first example that I'm going to do is it's already going to be in slope-intercept form for us. So for example, I'm going to graph y equals, let's do negative 2/3 x plus 1. Okay, so first of all, before you even start to graph, it's not a bad idea to ask yourself the question, is the slope positive or negative? Okay, because right off the bat, you'll know a little bit about what to expect of the line. See, this one has a negative slope right here. The coefficient of the x is always a slope. And so what that tells me is that this line is going to be falling from left to right. So this may not be what the line actually turns out looking like, but I know that it's going to be angled going downward. Okay? So that is just so that if I start plotting the line and I get something that's not going downward, I'll know, oops, I made a mistake somewhere. All right, so now I'm going to start my graphing using the fact that the slope is negative 2/3 and the y-intercept is the 0.01. Now, the 0, 1 is always your starting point. I shouldn't say 0, 1. The y-intercept is always your starting point. In this case, 0, 1. So always start by plotting that point first. So here's 0, 1. All right, now I know that this is a negative slope, so I know that my line is going to go something like this, right? So the next point I plot is either going to be up and to the left or down and to the right. So let's figure out what we're going to do here. So rewrite your slope in every, having a technical problem here. Here we go. Sorry about that. Okay. Hello, Daniel. Okay, so we're going to continue where we left off. Sorry. So we know we're going to have a negative slope, a falling line from left to right, and now let's figure out exactly what the next pair of coordinates would be by writing down our slope in two different ways. So the slope we were given is negative 2/3. In fractions, it doesn't matter where the negative goes. So either it can go out front, or it can go in the numerator, or it can go in the denominator. If it's in the numerator, -2 over +3. If it's in the denominator, +2 over -3. Okay, so let's say I wanted to plot a point that was up and to the left. Up is a positive rise, and to the left is a negative run. So that would be, this is the situation here. We're going to go rising up 2, and our run would be to the left 3. So I'm going to go up 2 and to the left 1, 2, 3. Now, a lot of times people have trouble doing this on a graph and seeing what the coordinates are. It looks to me like the coordinates are going to be -3, 3, but I'm going to show you a little trick that you can do. Remember, your rise is a change in your y value, and your run is a change in your x value. So if you go to that starting point, 0, 1, and you increase the x value by the amount shown here, well, actually it's a decrease in this case, -3, and you increase the y value by the amount shown here, +2, you're going to get the coordinates of that point. So -3, +3. So yeah, I labeled it correctly. So let's go ahead and draw in our line. It's supposed to be straight. Okay. So the next thing we're going to do is, just to show you, we could have also gotten a point that was to the right and down, and that would be this -2 over +3 way of thinking of the rise over run. So this would mean that our rise is actually down 2, and our run is actually to the right 3. So if I go down 2 and to the right 1, 2, 3, I'm supposed to be there with my line. So my line was a little bit off. It should have gone more like that. Okay, but what are the coordinates here? Well, if I've drawn my graph very neatly and I can read it, it looks like it's 3, -1. I could do the same little trick though. I could start with my 0, 1. Remember that going down is affecting the y, and going to the right is affecting the x. So I'm adding 3 to the x, and I'm subtracting 2 from the y in this case. And that's going to give me coordinates 3, -1. And that's what I had. Okay? So that's one example of graphing lines using slope and y-intercept. I want to do another example where we don't start with y equals mx plus b form, because it's possible, if you're making errors on your graph, that maybe when you actually rearrange the equation that you got that wrong as well. So let's look at another one. And let me know if you have any questions about anything that I'm doing here. You can just type it into the chat. Okay, so the last thing we're going to do today is this example, graphing lines using slope and y-intercept. Okay, but this time the example is graph the line, and let's do 2x minus y equals 4. Okay, so in this case, before we can actually identify the slope and y-intercept, we have to do some rearranging to get it to match with y equals mx plus b, the slope-intercept form of a line. So all that means is I need to solve for y. So I'm going to always do that the same way. Here I'm going to subtract 2x from both sides. You always move the x term first, as we talked about earlier in this session. So this is going to be negative y equals negative 2x plus 4. And then you're going to divide by the coefficient of the y, in this case negative 1. But remember, when you do that, you have to divide both parts by the negative 1. That's a very common error, to forget and only divide one part. So this is going to give us y equals positive 2, because negative 2 divided by negative 1 is positive 2, minus 4, so positive 2x rather. 4 positive divided by negative 1 is negative 4. All right, so we are going to have a slope of 2 here and a y-intercept of negative 4. The y-intercept is 0, negative 4. Okay, remember I told you that when you first look at it, before you even try to plot it, think about that slope. Is it positive or is it negative? The slope in this case is positive, which means that we would expect our line to be rising from left to right. Okay, it's going up. So keep that in the back of your mind as you graph so you'll catch mistakes. All right, so I'm going to draw the graph. And I'm going to look at 0, negative 4 is my starting point. 1, 2, 3, 4. Okay, 0, negative 4. All right. Now the next step is to use the slope to show me where I'm going next. Now my slope is 2. When you have a slope that's a whole number, you're going to think of it as being over 1. So in this case, we could think of the slope as being positive 2 over positive 1, but we could also think of the slope as being negative 2 over negative 1. I would write them both down even if you're only planning to use one of them, just so you can see what your options are. All right, now in this case, do you notice that I'm kind of at the bottom of my graph? So to avoid having to go down, I'm not going to use the negative 2 over negative 1. I'm just going to use my positive 2 over positive 1. And I'm going to do that little trick where I write the starting point, 0, negative 4. And I know that my y is going to be changed by the rise, and my x is going to be changed by the run. So I'm going to add the y value 2, and I'm going to add to the x value 1. So my next pair of coordinates should be at 1, negative 2. 1, negative 2 is here. Okay. Now notice if you did it the other way, if you said, okay, up to would be like this, and to the, oh, I just graphed it wrong. Sorry guys, bad teacher, I made an error. Okay, let's back up. So we found 1, negative 2, but I plotted it in the wrong spot. 1, negative 2, there we go. Okay. So if we had gone rise is up 2, we would have gone up 2. And if we had done run is to the right 1, then I would go to the right one, and I would have gotten to the same place. Okay? Assuming I did it right, of course. Let's see. And now I'm going to connect the dots. Don't forget to draw your line. A lot of times people get all that work done, and then on the test they just don't draw in the line. So remember to draw in your line and put your little arrows on the end, and you're good to go. Okay. All right, so any last questions before we log off today about anything we did? Okay. I know there's a little bit of a delay on the feed, so. Okay, well, it's a miracle. The feed lasted through the whole session, so that's good. So if there are no other questions, I'm going to go ahead and say goodbye to everybody. So, but remember, you can still send me email questions over the weekend. Do that as early as possible to give me time to respond, but you can still send questions if you have any, and keep working on your Alex, okay? Goodbye, everybody. Thank you for coming.